purpose of this video is to discuss the vacuum bag board building technology needed to produce the highest performance sailboards. Understanding this technology can save years of expensive trial and error. Anyone with this knowledge, along with a few tools, can build a board. A person who has already built a few boards on their own will easily produce a board similar to the best custom sailboards. A light, stiff composite blank is required to build these boards. This light sandwich blank can only be built by vacuum bagging. A typical sized, strong and tough board, made with care, should weigh about 14 pounds on average finished. Vacuum bagging is simply a powerful clamp used to apply equal pressure to the board exterior and vacuum table. Rigid, high-density PVC foam with fiberglass cloth saturated with epoxy resin can be clamped around a shaped styrofoam core and against a curved vacuum mold until the epoxy has time to set. Vacuum bagging is a tool for bonding and laminating. It will not magically reduce resin and weight. Vacuum bagging does allow a laminate to be condensed for a higher fiber to resin ratio. A blank that is vacuum molded by bagging against a good bottom mold results in an almost perfect bottom surface to start building your board. This video will cover all the steps required to vacuum build your board from design to finishing the last detail. With a vacuum pump removing the air from a sealed bag, the remaining weight of the outside atmosphere collapses on the exterior of the bag. The weight of the atmosphere is measured in inches of mercury. The average barometric pressure of 29 inches is equal to about 14.7 pounds per square inch that we all experience around us at all times. Remember that the clamping pressure provided by the atmosphere will be equal and will be from all sides. Pulling the full vacuum will crush a fragile foam blank. A small, deep vacuum pump capable of removing 1 to 3 cubic feet per minute of air is required. The bag will slowly collapse, and with a simple pin valve we can control the amount of air let into the bag. This will regulate the pressure to the desired 8 to 14 inches of vacuum. This converted into pounds per square inch is roughly 1/2 the amount, or 4 to 7 psi. Just 10 inches of vacuum, or roughly 5 psi, is equal to 720 pounds per square foot of clamping pressure. Vacuum pumps are available from both the scientific and refrigeration industry suppliers. An inexpensive vacuum pump can be made from the intake of a salvaged fridge or freezer compressor. To begin fabricating your blank, you will need to model it from an existing board shape suitable to your needs. Try to have this model to refer to while you are working. It will be necessary to transfer the important measurements from the model to a paper plan shape pattern. You can use a roll end of newsprint or brown wrapping paper for this purpose. To begin, record the mast track and footstrap insert measurements from the tail end of the model. These will be used later. Now, roll the pattern paper onto the bottom of the model board. And secure it with masking tape. Using a carpenter's crayon, mark the hard edge of the perimeter as shown here. Follow this by measuring several centerline points down the pattern and draw in the centerline from the tail to the nose. Draw in 3 key measuring points, 90 degrees to the centerline, 12 inches from the nose, 12 inches from the tail, and the wide point of the board. These key points will be used later with our spin template to mark the board's plan shape. Additional reference lines can be drawn in to help gather the board's profile details. On one side of the pattern only, use a profile gauge to model the amount of tuck and rail shape. Trace the profile shape at each reference line for future use. Use the carpenter's crayon again to shade in the fin box slot. Now, refer to the measurements taken earlier for the mast track and foot strap insert locations and transfer these to the plan shape pattern. Foot strap insert locations can be easily recorded and later transferred using a separate template, such as this one. Once all the pertinent measurements have been recorded, the plan shape pattern is finished and can be cut out with a pair of scissors. An outline spin template is best made from 1/8 inch mahogany plywood. This material is inexpensive and is easily worked with common tools, such as a handsaw, razor knife, block plane, and sanding board. To begin, cut a 16 inch wide by 72 inch long piece from the 1/8 inch plywood sheet. Using your paper plan shape pattern, transfer the curves to the plywood, with the nose end curve on one side of the template and the tail side curve on the other. Carefully cut the template to shape, taking time to block plane and sand the curves accurately. This will produce a professional template used by many board shapers. The outline spin template will be used later to mark the board's outline curve. To begin fabricating the board's bottom, place appropriately sized pieces of high density foam on the work table. Using a long straight edge, draw a center line down the length of the sheet. Next, mark in the 3 key measuring points, 12 inches from the nose, 12 inches from the tail, and the board's wide point on the center line. Transfer these marks outward to the outline with a square. Refer back to the paper plan shape pattern and transfer the key dimensions onto the high density foam. Remember, you will be wrapping the rails with additional high density sheet foam. The paper plan shape pattern can also be used for drawing in the last few inches of the nose and tail. The spin template is used as a curve to connect your marks. Mark one side of the outline curve, tail to mid-board. Flip the template over to mark the other. Flip the template end for end to mark the nose side curves. Take a few moments to check the outline. With a razor knife, rough cut and allow an extra 3/8 of an inch each side. This will be trimmed up later. Tape any joints in the bottom with masking tape and store this high density bottom safely away to be used later. To make a rocker copy template, fasten 10 feet of 16 inch wide 1/8 mahogany plywood to a 10-foot 1x4 stiffener, as shown here. Hold this template over the bottom of the model board center line and scribe a line down the plywood using a marker and a thick block of wood. Rough cut the excess material off. Place the template back over the board and repeat this scribing and cutting process until the curve is near perfect. The final scribed line can be block planed and sanded until the template matches the board's rocker line perfectly. We can now use the rocker copy template to make a pair of thickness flow templates to be used as guides while hot wire cutting the board's foam blank. Trace the board's bottom profile onto a suitable piece of 3/8 plywood. Use homemade calipers to measure the model board's thickness every 6 inches. Remember to subtract the thickness of the high-density foam layers on the top and bottom of the finished board. Transfer these measurements onto the 3/8 inch plywood. When this is done, connect the marks with a pencil and ruler and cut out the template with a jigsaw. After duplicating a second template, screw both of them together and block plane and sand until they are both identical. Applying a strip of masking tape to the edges will allow the hot wire to slide smoothly down the templates. Finally, drill 6 1/4 inch holes along the templates for attaching to the EPS foam block. With a bit of understanding, hot wire cutters are easily built. For board building, 2 different size cutters will be needed. The larger of the 2 cutters will be used to cut large slabs from your full-size foam billet. This cutter should have a throat size at least 3 inches larger than the width of the foam billet. The depth of the cutter should be about 9 inches. The smaller of the 2 cutters will be used to trim the plan shape and also to bevel the deck. This cutter will require a narrower throat size about 6 inches, but will need a fairly deep cutting depth of about 14 inches. Both cutters are fabricated from 3/4 inch plywood, similar in shape to a C-clamp. A metal screw is located at the upper and lower ends of the throats as a fastening point for the cutting wire. Both cutters must have a tensioning device because the wire stretches as it heats. A 12-volt car battery or an electric train transformer works as a power source to heat the cutting wire to operating temperature. Run 2 7-foot 16-gauge shielded copper wires from the transformer and terminate them with insulated alligator clips. Secure 18 to 20 gauge nickel chromium wire between the screw fasteners. To power up the cutter, connect one alligator clip to the screw furthest on the cutter and the other clip to the location on the far side of the opposing screw, which provides the correct resistance. If your transformer is adjustable, you may be able to connect each clip to the fasteners and adjust the temperature at the transformer knob. Make a series of practice cuts to determine what settings work best for your cutting unit. Remember to disconnect the power from the cutter and turn off the transformer when the cutter is not in use. A large styrofoam billet, 32 by 24 by 120 inches, is preferred for hot wiring. A 32-inch billet will give you 5 to 6 board slabs. Take time and care to align the templates on the billet to waste as little foam as possible. Screw the thickness templates on each side of the billet. Turn on the hot wire. Practice cutting some of the waste at the nose and tail. With the wire hot, enter the billet and begin cutting slowly along the edge of the templates. If the center of the wire lags far behind, take extra care to adjust the tension on the wire. These large billets are usually used for dock flotation. The billets can be ordered through marine, roofing, or insulation supply companies from the manufacturer. When ordering this foam billet, ask for 3/4 to 1 pound per cubic foot density. Also ask for a small, tight bead structure that is well bonded together. After the foam slab is cut out, loosen the screws on the templates and tip them to match the board's V. The hot wire will not easily cut through masking tape. For this reason, remark the V's center line and cover with a quality 3/4 inch masking tape. Slowly make the V cut. With the wire sliding along both the center tape that provides the wire from cutting under the tape and the lowered templates. This cut should also match up with the vacuum table's V setting. Remove the tape and move the styrofoam slab to the work stands. With a long straight edge, remark the center line on the bottom. Also remark and check the length, tail, and nose thickness. Use the plan form outline template to mark the outline, or just use the high density foam bottom outline. Mark the rough outline and cut 1/2 inch wider than the template. This gives plenty of room for error when aligning and gluing the bottom on. There are many styles of vacuum molds and tables that can be built. For example, a bottom mold can be taken from an existing board, or by making curved rocker plates, or by covering wood stringers with plywood. The adjustable rocker table allows the most varied board styles and rockers to be built. A mold needs only to be stiff enough to hold its shape under vacuum and allow for a tight air seal. It is best to avoid bagging with just a bag and without a mold to prevent distortion and twisting of the blank. An inexpensive mold that allows for rocker changes is to use the remaining hot wired foam billet after taking the blank off. I would recommend this to anyone building only a few boards. The only cost would be the extra 6 mil poly bag and sealant tape to cover the entire billet and blank. The hot wire V-cuts can be placed back on the block and covered with 1/4 inch masonite to stiffen the rocker curve. Always protect your table's smooth finish with a mold wax or plastic polyfilm to prevent the epoxy from bonding. Before mixing any epoxy resin, it is important to know a few rules. The key to successful epoxy use is in correctly mixing the resin and hardener ratio. Always determine the amount of resin you will need, then calculate the amount of hardener according to the manufacturer's instructions. Always thoroughly mix the resin until it's completely blended. Use epoxy only in areas with good ventilation and avoid all direct skin contact. Epoxy is available with different hardeners. A slow hardener is good when putting inserts and boxes deep into EPS foam because it will create less heat in bulk. A fast hardener is best for surface sanding and fairing mixtures. This hard resin also prevents sanding too deeply into the fiberglass. A laminating resin that allows a long working time is best for bagging. There are many fine powdered additives for thickening the epoxy. Always add these later after the epoxy has been thoroughly measured and mixed. Always wear a dust mask when mixing or sanding these powdered epoxy additives. Because any spilled wet resin will completely prevent a seal on the vacuum table, the first part of the layup sandwich must be done on a second flat surface. Set up a 10-foot long table or temporary workbench. Tape any joints in the high-density foam from the bottom with a quality masking tape. This masking tape will contain the resin in the joint, resulting in an excellent bond of the edges of the high-density foam ends. Roll out your 4-ounce glass over the bottom high-density foam outline. Cut any extra fiberglass cloth reinforcement such as around the fin box and prepare any foam stiffeners and fiberglass reinforcements in the styrofoam if required. For the bottom, mix up roughly 700 milliliters or 19 fluid ounces of epoxy. This amount will depend on the size of the blank. Pour part of the resin in a line down the center line. Let it have a chance to penetrate, especially near any joints in the bottom. Use your squeegee to move the resin around and out towards the rail. Add more resin as required. Work it in and completely wet out the cloth on the high-density foam. Use enough resin, but do not starve or oversaturate the joint. With some patience, the resin can be spread quite far. Extra resin is extra weight. It will not add more strength if there is already enough resin. Trim any excess cloth with a pair of sharp scissors. Some weight-saving and bonding tips are to mix up microspheres with some of the resin and fill the coarse surface of the high-density foam before covering with cloth. Another tip for a long-lasting board is to install a long 1.5 inch deep 1/4 inch high-density foam stiffener routed into the styrofoam bottom. Wrap this with a 5 inch wide cloth strip, wet out and install. By folding back the extra wet cloth onto the blank, it will form a T-shaped reinforcement, which will strengthen and protect the bottom from delaminating. Transfer the wet and readied high-density foam bottom to the vacuum table. Center the PVC foam bottom onto a protective sheet of poly on the vacuum table. Now get the styrofoam core ready. If any internal high-density bottom stiffeners or blocks around the fin box are prepared, install them at this time. Place this core on the wet-out glass cloth and high-density bottom. Use the styrofoam core's marked center line to recheck that it's correctly positioned over the wet-out bottom. There are many ways to seal the vacuum bag, including clamps and frames. A roll of sticky butyl tape, the kind used for glazing windows, is about the simplest and can always help if you have a minor leak. A sheet of 6mm heavy-duty poly makes a good bag for the pressures we are using. First, apply a bed of butyl tape to the outer edge of the vacuum table, pressing it down thoroughly. Lay the 6mm poly over the table, leaving plenty of slack in the bag. Start to seal the bag by pulling the paper tape and rubbing the poly onto the soft bead. Later, the bag will pull very tight, so make a few loops of extra bag material. And seal them with butyl tape. Before closing the bag, insert the vacuum hose, also wrapped in butyl tape. Make sure this is sealed. This hose can also be permanently installed in your table's bottom. Always ensure that there is a free passage of air to the vacuum pump. Start the vacuum pump and check for air leaks. The bag will not have any clamping pressure unless the pump can remove more air than is coming in. Check the positioning of the blank components as the bag slowly collapses. 8 to 14 inches of vacuum is ideal. This is roughly 4 to 7 pounds per square inch. Greater pressure for too long may crush or damage the core foam. As you get a good seal, you can hear and find tiny air leaks. When the styrofoam starts to form small bead bumps that look like lumpy cottage cheese, it is probably more than enough pressure. Slightly back the pressure off with the pin valve letting the air in. The vacuum gauge should read about 10 inches. Double check that your seals are holding. A vacuum bag may be pulling itself off the beads. Also check for the first few hours to ensure the pressure is not crushing the project. If you have a timer, you can set it to shut off the pump. I like the pressure to be on for at least 8 to 12 hours for epoxy that sets up in roughly 8 hours. Time is up. Turning off the pump will let the air in. Carefully pull back just a side corner of the bag as it will be reused. Ease the blank out and off the table. Check the blank. It will feel much stiffer and should have an excellent bond. If you have applied a little too much pressure to the styrofoam, it may look like it has too much rocker, but this will return to normal. The rocker will be later locked in when the deck is bagged. On the work stands, bottom up, remark the center line and plan form. Remember, the rails will be wrapped with an additional high-density foam. Use a razor knife and at this time carefully cut on the line through the high-density foam and 4-ounce cloth. Peel back the excess high-density foam. Set up the short hot wire cutter to cut at 90 degrees. With the blank bottom up, cut just along the edges of the high density foam and any extra EPS foam will just fall away. Your outline may need only a light sanding and smoothing to be perfectly squared to the bottom of the blank. Avoid hot wire cutting the PVC foam as toxic fumes will arise from this. Do not breathe these fumes. Turn the blank deck side up. Using a good dark felt pen, find and mark the center line on the deck. Use the outline template again to position and mark the deck slope, deck lines, and rail slopes. A combination square will mark guidelines at the rear of the board. Don't cut all the foam away with the cutter, but cut enough to get a good symmetrical start. Take some time to get the angles and depth needed. Use the adjustable hot wire cutter to remove the excess foam. Shaping the deck with a Surform plane, and then a 40 grit paper on a sanding board. Take care to remove the same amounts of foam from each side. Check the model again. Continue shaping and sanding. Take some time, stand back and look. A good tip is to use lights to look for uneven shadow lines. Finish sanding with 120 grit screen mesh on the rails with the board on edge in the workstands. Turn the blank bottom up and mark the tuck on the rails and bottom. Slalom and course boards have boxy rails with a flat, thin forward deck. Wave and bump and jump boards have a domed deck with low rails. More tuck makes the board more maneuverable. Less tuck gives it earlier planing. Carefully check over the rear and sharp rails of your model. Mark all the details and make cardboard rail templates to help with shaping. Remember that you will cover the deck and rails with high density foam, so make the allowances in thickness and width. Carefully shape and sand the bottom tuck line. Take extra care when sanding the two different density foams. A tip is to masking tape the wide point on the styrofoam rails to prevent sanding them away. Finish sanding the tuck with the screen mesh. Remember, the high density foam wrap that covers the rails can be sanded and fine-tuned later. Set up the router to cut a 1/4 inch wide by 2 inch deep slot roughly 16 inches long to reinforce the deck at the mast track. In addition, stronger jump boards can have a short heel reinforcement slot cut for T-shaped deck stiffeners. Fit the slots with high density foam scraps and trim flush with a razor knife. Redraw the center line on the deck of the blank. Mark and draw lines at right angles to the center line every 6 inches for the entire length of the blank. Use a large square to extend the lines out. Draw a few extra lines at the nose and tail where there's lots of curve. Using a soft tailor's measuring tape, measure the curve of the deck from rail to rail at each line. Add an additional 1 3/4 inches to the measurement. I like to clamp a block to take up this additional 1 3/4 inches on the tailor's tape. Write down all the measurements on the blank. Because of the widths required, it is best to lay out the deck from a new 4 foot by 8 foot high density foam sheet. Mark this foam sheet from the side, because there is less waste as the nose and tail tapers will match each other. Draw a center line and the same parallel lines on the deck high density foam sheet. Divide the measurements and chart the marks from the center line. Continue lofting and cut out these 3 high density foam deck pieces. Rough fit the pieces and masking tape all the deck pieces together. For the high density foam to wrap around a compound curve, relief darts must be cut at the nose and tail. Don't be afraid to cut out a little extra. This sample of video shows a lighter weight 1/8 inch high density foam for lighter boards, but 1/4 inch will also bend over the rails. When the high density foam is bent around too tight a curve, it will crack. A good tip is to add a wide strip of masking tape to the outside of the high density foam at the most curved spots to reduce cracking. Because the high density foam and glass will wrap and hang past the bottom edge of the board, it is necessary to elevate the blank on a solid lift while vacuum bagging the deck. On the workstands, turn the blank bottom up. Apply masking tape at the edge of the bottom to prevent the resin and glass from sticking. Lay out a 1 1/2 inch thick solid blue extruded styrofoam outline and cut it 3/4 of an inch all around smaller than the blank. Tape the edge of this foam outline and install the styrofoam lift to the board bottom with long wood screws. A short, changeable centerpiece will allow you to reuse this lift on several board sizes. On the workstands, test fit the high-density foam pieces. On a separate work table, lay up the deck as we did before when laying up the bottom. Include all the extra cloth and carbon reinforcements in the mast track, foot straps, fin box, and nose. Mix up roughly 900 milliliters or 28 fluid ounces of resin. Again, use enough resin not to starve the joints. Install a high-density block or any internal T-shaped stiffeners at the mast box area, also under the heels of jump boards. Paint some thickened resin on the bottom edge of the blank. This will ensure that the high-density foam does not start to flip up when removed from the vacuum bag. With the blank on the workstands, turn over and transfer the wet-out high-density foam deck onto the blank center line. And secure it into place with a few long wood screws. With the blank still on the workstands, cut a 4 mil medium poly to hang down past the rails. Use a packing tape gun and pull the poly tight around the blank to pre-bend the high-density foam for vacuum pressure. This will force the vacuum bag to push the high-density foam down and around the rails, and stopping the vacuum bag from forcing itself under the edges of the high-density foam. Place and center the blank assembly on the vacuum table's center line. Cover the blank and seal the open side of the existing poly bag with new butyl tape. Check the installed vacuum tube and start the pump. Check the center line alignment as before. Work the butyl seal until the bag collapses with sufficient pressure. Use your hands to force down any trouble areas on the high-density foam. Trouble spots are at the tail, nose, and especially any soft rails. Use the pin valve again to regulate the pressure. Continue to monitor the blank as before. Turn off the pump and open the seal 10 to 12 hours later. Remove the board blank assembly to the work stands. Set the blank bottom up. Cut the packing tape. Remove the poly and unscrew and remove the blue styrofoam lift. Trim off the excess high-density foam overhanging the rail with a razor knife. Remove the protective masking tape from the board's bottom. Examine and rough sand the blank as required. Fill any low spots, cracks, holes, and joints with a thick mixture of light fairing epoxy. Make sure there is a small hole venting the blank. Allow to heat cure in a warm room or heated box. This will strengthen the bond between the materials. After post-curing, remove and sand the blank with 40 to 60 grit sandpaper on a rigid sanding board, sanding any high points, and continue to refine the shape and rails until you are satisfied. The advantage of the high-density foam and glass now covering the blank is that the board's fin box, mast track, inserts, and vent can be installed before glassing. This allows for laminating the blank with the inserts in place. This eliminates the need for capping the components later, as is done with heavier polyester glass boards. Carefully redraw the centerline on the top and bottom. Measure and mark the locations of the fin box, mast track, foot straps, and vent components. The type of board, sailor's height, weight, and ability will also determine the placement of foot straps. Straps should be placed further back and out on a slalom board, further forward and in on a bump and jump or wave board. Multiple foot strap inserts will allow a sailor to change up his or her sailing style. The mast track usually starts 51 or 52 inches from the tail, and this is much further back than was done a few years ago. The fin box location depends on the type of board as well as the type of fin. For example, a race board with a blade fin will have its box mounted further back for directional stability and speed. A bump and jump board with a high aspect swept fin will have its fin mounted slightly more forward to loosen the ride. A wave board with its low aspect swept wave fin will be mounted even more forward. The sailor's weight is back and out on the board when racing and is more forward and inboard while doing transitions. Some sample guide positions for a Tuttle fin box are 3 to 4 inches for slalom and course boards, 3.5 to 4.5 inches for bump and jump, 4 to 5 inches for wave boards. Unless building an AVS board, the tip of a swept fin does not extend past the rear tip of the board itself. All fin boxes should be set into a solid, high-density foam block or purchased as a pre-built foam cassette. To install a cassette Tuttle fin box, it is best to cut out for the fin box with a good, accurate template and router. This cut from the bottom will be right through the top deck of the board. Trial fit and plumb the fin box cassette. It should be a light friction fit. Mark the top excess at the top deck and allow for the curved deck. Remove and cut off most of the excess fin box material. Mix up a small 100 milliliter or 3-ounce batch of epoxy thickened with microspheres. Butter the cassette and cavity. Install the fin box from the bottom surface 1/32 of an inch below flush. This will allow for an extra fiberglass reinforcing patch over the box. Recheck the alignment. Use a guide stick to plumb and square the box with the board. Foam wedges and screws can be used to plumb the box from below. Note the use of 2 hand levels, one on the bottom surface of the board and one plumb on the guide stick. Allow to cure. Later, grind and sand off the excess box from the deck. Mark the top deck for centerline. Lay out the locations for the footstrap inserts, mast track, and vent. Locate the position of the Tuttle fin box through bolts by inserting a fin from the bottom of the board. Mark these bolt positions on the deck. Make router templates for cutting the mast track, footstrap inserts, and vent. Once cut with a razor knife, the high-density foam makes great router templates. After a vacuum pump and hot wire, which are required, a good plunge router is the most desired power tool for vacuum board building. When cutting or routing out for the insert plugs, they should be flush but not too snug. When installing a mast track or an A-type fin box without a cassette, route a cavity that allows for 3 layers of 4-ounce cloth and the box. I also like to route a slight deck depression in the high-density foam around the box for folding the cloth back down. Wrap the cloth around the box, then check the fit and the alignment, especially if it is a fin box. To prevent unwanted resin from sticking inside the box, apply PVA mold release to the inside surfaces of the box. Cover the slot with quality masking tape and rough sand the exterior of the box for a better bond. Mark the front and back of the box on the masking tape. Mix up 200 milliliters or 6 ounces of resin with a slow hardener. Saturate 3 pieces of 7-inch by 12-inch 4-ounce cloth with resin on a scrap of poly. Mix the remaining resin with microspheres and fill the cavity 1/4 full, wetting out all sides with the mixing stick, including the deck depression. Butter the mast box sides and bottom with the thickened resin. Also apply some of the resin to the wet out cloth. Wrap the box with the cloth and remove the plastic. Push the box into the cavity until flush with the deck. With the pressure forcing out the excess resin, squeegee down the extra cloth onto the deck depression. Cover with poly or peel ply and force the air out. Cover with a sponge foam pad and add a flat weight until cured. If you are using an American type slotted box as a fin box, Increase the cloth and make sure the box is set into a solid insert of high density foam. Use a strap clamp around the blank on an alignment stick or fin to align the fin box. The inserts can be installed at the same time as the mast track. When installing a molded plastic vent, remove the plastic screw and O-ring. Cover the ends of the vent top and bottom with masking tape. With a small stir stick, fill the insert cavities half full of thickened resin. Stir resin up the sides. On a scrap piece of poly, butter the rough sanded inserts with thickened resin. Push them into the cavities and remove the excess resin. This is also the time to cut and install a high-density foam backing to cover over the Tuttle box deck slot. Any extra resin can be used on areas such as the darts at the nose and tail. Allow the resin to cure. Mark the top deck for centerline. Lay out the locations for the footstrap inserts, mast track, and vent. Locate the position of the Tuttle fin box through bolts by inserting a fin from the bottom of the board. Mark these bolt positions on the deck. Make router templates for cutting the mast track, footstrap inserts, and vent. Once cut with the razor knife, the high-density foam makes great router templates. After a vacuum pump and hot wire, which are required, a good plunge router is the most desired power tool for vacuum board building. When cutting or routing out for the insert plugs, they should be flush but not too snug. When installing a mast track or an A-type fin box without a cassette, route a cavity that allows for 3 layers of 4-ounce cloth and the box. I also like to route a slight deck depression in the high-density foam around the box for folding the cloth back down. Wrap the cloth around the box, then check the fit and the alignment, especially if it is a fin box. To prevent unwanted resin from sticking inside the box, apply PVA mold release to the inside surfaces of the box. Cover the slot with quality masking tape and rough sand the exterior of the box for a better bond. Mark the front and back of the box on the masking tape. Mix up 200 milliliters or 6 ounces of resin with a slow hardener. Saturate 3 pieces of 7-inch by 12-inch 4-ounce cloth with resin on a scrap of poly. Mix the remaining resin with microspheres and fill the cavity 1/4 full, wetting out all sides with the mixing stick, including the deck depression. Butter the mast box sides and bottom with the thickened resin. Also apply some of the resin to the wet out cloth. Wrap the box with the cloth and remove the plastic. Push the box into the cavity until flush with the deck. With the pressure forcing out the excess resin, squeegee down the extra cloth onto the deck depression. Cover with poly or peel ply and force the air out. Cover with a sponge foam pad and add a flat weight until cured. If you are using an American type slotted box as a fin box, increase the cloth and make sure the box is set into a solid insert of high density foam. Use a strap clamp around the blank on an alignment stick or fin to align the fin box. The inserts can be installed at the same time as the mast track. When installing a molded plastic vent, remove the plastic screw and O-ring. Cover the ends of the vent top and bottom with masking tape. With a small stir stick, fill the insert cavities half full of thickened resin. Stir resin up the sides. On a scrap piece of poly, butter the rough sanded inserts with thickened resin. Push them into the cavities and remove the excess resin. This is also the time to cut and install a high density foam backing to cover over the Tuttle box deck slot. Any extra resin can be used on areas such as the darts at the nose and tail. Allow the resin to cure. Now is the opportunity to perfect the blank before glassing. Time spent fairing the high spots will save the weight of fillers later. Use 40, 60, and 80 grit sandpaper on a long sanding block. Proper sanding strokes should be at 45 degrees to the board. Sand the whole board equally. Reverse and sand at the opposite 45 degrees. Let the stiff sanding board work as it hunts and sands down any high spots. Also sand end to end, but holding the sanding board at 45 degrees. Use a rolling motion when sanding the rails at 45 degrees one way and 45 degrees the other. One can tell when it feels right. Finish sanding the slope deck and rails with the encrusted sanding mesh. None of the inserts or boxes should protrude past the deck, and they should have a rough, scored surface for bonding, with no masking tape on the plastic surfaces. The amount of glass and high-density foam can be customized for each board or sailor. But have a goal in mind such that the finished board is to be 14 pounds regardless of its size. This means that a small high-wind jump board will have a thicker, stronger skin than a 9'6" course racing board. The bottom skin on the course racing board can be as little as one layer of 4-ounce glass over 1/8 inch high-density foam. The bottom skin on the small jump board can be 2 layers of 6-ounce glass over 1/4 inch high-density foam. One layer of 4-ounce glass leaves very little room for sanding error. For this reason, it is more practical to use a second layer of 4-ounce or 6-ounce cloth with an additional 2 layers of cloth as fin box patch reinforcement. The deck should match the bottom except that it has additional tail to mast box layer of 4-ounce S-glass. In addition to the mast box, foot strap, and heel patches, we must also reinforce the skin over our Tuttle type fin box through bolts. Today's flip noses are a target for damage. A little extra cloth reinforcement will save repair and refinishing later. I tries to use a little carbon over the load areas, but not so much as to give the board a stiff feel. During the laminating process, the board rails will be glassed twice. Notice in this shot of video that the bottom has been laminated, allowed to cure, rough sanded, and filled with a fairing compound and finished sanded. The rail wrap coming up from the bottom has been faired so smoothly to accept the deck and rail lamination it is barely visible to the eye. This 2 to 4 inch double laminated area, referred to as the rail wrap, will provide stiffness to the board while protecting the rails from damage.
The process of laminating the bottom of the blank is the same as laminating the deck. The bottom will be laminated separately and allowed to cure prior to the deck lamination. To avoid duplication and save a bit of time, we will show the deck lamination while making comments about the bottom. You will also be able to refer to the written laminating instructions supplied with this video. Before laminating the deck, it is wise to protect the bottom lamination from unwanted epoxy and fiberglass. Apply a 1-inch wide quality masking tape to the flat bottom slightly overhanging the rail. With a file or sanding block, carefully sand through the tape to the rail line. This will leave a good straight line to end the deck rail wrap. Protect the remainder of the bottom with poly. Cut and fit any carbon reinforcements for the mast and fin boxes and footpad areas prior to laminating. The mast and fin box interiors should be coated with PVA wax to protect them from unwanted resin. If carbon fiber is to be used on the deck, make a paper map of the insert and bolt positions. The deck will require about 800 milliliters or 24 fluid ounces of laminating resin, while the bottom will require slightly less depending on the amount of cloth used. Since it is messy to squeegee the underside of the rail tuck, it is easier to first turn the board over to paint the rails with resin. Now flip the board back over. To start, place a piece of 4-ounce S-glass over the open mast box. Use a brush and squeegee to carefully wet this piece out. The fine, tight woven cloth will prevent epoxy from running down into the box. Wet out the other reinforcements at the mast track, tuttle bolts, and heel patches. Next, roll out a tail to mast piece of cloth onto the deck centerline and smooth it out. Pour a line of resin down the centerline and work it in with a squeegee. Spread the resin evenly and sparingly over the cloth, working it out towards the rails. With the cloth secured, use the shears to cut the excess 1 inch beyond the rails. Place a reinforcement patch at the nose and continue to wet out the first layer and rails. I prefer to saturate 1 layer of cloth at a time to ensure they are fully wet out. If the tail to mast box layer is too rich, the first or second full-length layer will absorb any excess resin. Use a fair amount of pressure on the squeegee and keep it moving to distribute the excess resin to the drier rails. Use a brush to completely wet out the bottom of the rail areas, followed with a squeegee. An option when the laminate is completely wet out is to sprinkle a few handfuls of dry microsphere fillers onto the wet fiberglass. With a gloved hand, work them into the laminate. These fillers will help fill the weave, making sanding easier while protecting the cloth. I prefer to wrap the exterior layup with a light or medium poly stretched over the wet laminate. The advantage of this is to reduce air from the laminate and snug down any overhanging cloth wrap on the rails. This allows for less sanding and fairing of the rails. If peel ply is used on the laminate, it must be applied now under the poly wrap. Peel ply is a special fine weave
no-stick nylon cloth for vacuum bagging. When used over an epoxy laminate, it can be later removed along with excess hardened resin. It is applied like cloth, but air and resin can be moved under it easily with a squeegee. It is more economical for weight savings to just use less resin. Spread the 4mm poly over the board Cut the poly to overhang a few inches past the rail wrap. Lightly rub the laminate through the poly. Use a packing tape applicator gun and start tagging the poly edges from one side to the poly edge of the other side. Turn the board over. And continue to pull and stretch the poly using the natural stretch in the poly and tape. After the poly is secured tight, take a little extra care to secure the nose and tail folds tight. Turn the board over and start rubbing the poly. Notice the air under the poly. With a sharp point, poke a few holes in the poly and work the air out of the laminate through the holes. Most custom board builders will just lay up the board without vacuum or even without the poly wrap. It is best, although not required, to vacuum bag for a good lamination. It is now simple to throw the wrap board into a large butyl sealed poly vacuum bag or to bag the blank against a good bottom mold. When bagging, a slightly drier layup is best, because an overly wet layup will tend to pull the resin towards the suction while under vacuum. A note of caution: since the blank is now completely covered with glass, it is possible for the wet laminate to bubble up from expanding air escaping from inside the foam. Temperature control at this point is very important. Avoid leaving the curing laminate in a room where the temperature is rising. This will cause air inside the blank to expand and try to escape through the wet glass. Once the laminate is hard and the poly removed, open the board's vent hole and heat cure according to the manufacturer's instructions. After the board is removed from its plastic wrap, trim the excess fiberglass from the rail with a razor knife. The surface should be now smooth and slightly fair. Take some time now to find and mark all of the inserts by dimpling them with a small countersink drill bit. Do the same at the ends of the fin box and mast track. Open up the board's vent hole, especially if there is any chance of creating unequal pressure. Sand the board completely from tail to nose using 40 to 60 grit sandpaper on a stiff sanding board. Again, use long sanding strokes at 45 degrees to the board one way and 45 degrees to the board the other way, being careful not to cut into the glass fiber of the cloth.
When this is done, mix 4 ounces of fast-setting resin with a thickened fairing compound and squeegee this mixture thinly over the entire board, top and bottom. This second coat will help fill those tiny pinholes in the fiberglass weave. After the fairing coat has cured, sand the whole board with 60 to 80 grit sandpaper on a stiff sanding board. Keep an eye open for low spots and be careful not to sand into the glass fiber layers. Dust the board off thoroughly. If required, another epoxy fairing or sanding coat can be applied. Another recommendation is to use a high-quality, lightweight polyester fairing putty applied to the whole board. Sand this layer starting with 100 grit, processing through 120, 150, 180, and finishing with 220 dry grit on a sanding board. Take your time and sand the board completely. When this is finished, clean out the insert dimples with a small countersink and dust the board off. Priming the board will require 1 quart of 2-part urethane high-build sanding primer. This primer can be applied with either a roller or a spray gun. If you have done a good job of sanding, 1 coat should be enough to hide any remaining scratches and pinholes. Sand the primer with 180, 220, and 320 grit sandpaper, starting with a small sanding block and finishing with a hand sanding pad until the board is near perfect. The finish coat of 2-part linear polyurethane aircraft or marine paint can also be rolled or sprayed. This paint is very flexible, durable, and waterproof. Always choose a white or light shade of paint, as it will attract less heat from the sun. These paints are very toxic and should be used in a proper spray booth using an air feed supply respirator and proper protective clothing. I spray the bottom and rails first and allow them to cure. This allows for any minor touch-ups to scratches and pinholes on the rails. Next, paint the top side of the board, being careful to apply an even coat that covers the primer completely. After the paint has cured for 12 to 16 hours, use 600 grit wet sanding paper or a power buff on any imperfections or runs. I like to mark my non-skid texture line with a block clamped to a soft tailor's tape. This allows for long, even, symmetrical guidelines with just a little adjustment at the nose. It is then easy to tape the outline using a high-quality auto paint masking tape. Make sure the light pencil marks are not in the non-skid. Tape off the rest of the rails with a wax paper to protect from any runoff. Foot pads can also be marked and masked out. The board is just plain, one color and a little bit boring now. Large, dark deck colors will attract heat. Avoid deck paints and printed decals because they may clash with the solvents in our non-skid and dissolve into a mess. Mixed colored paints are also hard to match if a repair is ever necessary. This is the time for a professional looking design, not a mistake. A good solution is an adhesive-backed solid colored vinyl. These decals are computer designed and cut by sign makers. Just choose the designs, colors, letters, fonts, and numbers to any size. These are solid colors that, when under the protection of the non-skid, will last without fading. They will be correctly spaced on an easy-to-apply special release tape. Just align, touch down, and rub from the center out. Then remove the tape and on to the next decal. The non-skid system that I show here is the best, clearest, and longest lasting that I have found. The non-skid resin is the same high-quality 2-part polyurethane aircraft marine paint, but it is clear without color pigment. The best non-skid dust I have used is acrylic foam dust. It is very fine and worth the extra cost. When all the masking and decals are ready and the non-skid dust is in a can peppered with holes, mix the clear paint components. Allow a few minutes for the paint to stand. It is best to spray the non-skid in coats and use the compressed air to blow away any extra non-skid dust. Using a good paint roller will produce good results. Just take a few seconds to make sure that the paint is rolled evenly without streaks. Sprinkle the dust, making sure that all the areas are covered. With clean hands, tap the board from the bottom of the board, hard enough to move the excess dust around. Allow just a few minutes and pull all the masking tapes off. Let the paint cure overnight. The final details of opening up the boxes and inserts are best done with a router. It is now obvious how important dimple marking is. For the mast and fin box slots, drill a hole just large enough for the router bit. Routing the slots is best done with 2 different flush cutting router bits. A 1/4 inch small flush cutter with a solid steel ball for mast racks and American type fin boxes. Take care not to let this heat up and burn into the side of the plastic box. A 3/8 or 1/2 inch ball bearing flush cutting bit will clear out Tuttle or power boxes. Never leave a fiberglass edge that can be lifted off the box. Always finish boxes by beveling the glass edge with both a flat and round files. Now, use water to dissolve the PVA mold release in the boxes. This will also release any unwanted epoxy. Sometimes a little work with a razor knife is necessary. Insert a tight-fitting fin and test fit the boxes. For Tuttle and power type boxes, carefully align and drill the fins through bolts. For American style boxes, check for any resin in the tab track. With a small countersink and drill bits, clean out the dimpled footstrap screw holes. Test fit the screws, make sure they are the right length and are not longer than the plugs. The stainless screws should be snug but easily turned. Ensure the top glass is beveled back
preventing the screw threads from picking up the laminate edge. Clear the vent hole with a large countersink bit. Clear the threads and test fit the supplied O-ring vent screw. For installing foot pads, carefully apply contact cement to both the pads and the board. Allow this to dry. Realign the pads and press them down. Screw down a new set of foot straps. Wash off any dirt or hand marks. Use 600 grit wet sandpaper to take the bite off the sharp non-skid. Your board is now ready for the showroom or for the beach and some real fun sailing.